Once again, I welcome you all for Standard 10th, subject Science and Technology, Part 2. Students, we will be continuing with chapter number 5, Towards Green Energy, Module 2. My name is Ms. Jagjeet Kaur. Students, before beginning with Module 2, let us see the learning objectives. So today you all will be understanding about power plant based on nuclear energy. Under power plant based on nuclear energy, we will be learning how the energy transformation in nuclear power plant takes place, then formation of nuclear energy, advantages of nuclear energy and problems of nuclear energy. Then along with that, we all will be understanding about the power generation plant based on energy of natural gas. And under that, we will be understanding the energy transformation in power plant using energy of natural gas and the advantages of power generation plant using natural gas. So before starting with module 2, let us recall what we have studied in our previous module. So we studied that energy is very basic and primary need. For various types of work, energy is needed in different forms. Then energy can be converted from one form to another by transformation. Michael Faraday invented the principle of electromagnetic induction, and this principle is largely used in generation of electricity. Then according to the principle of electromagnetic induction, a potential difference is generated across the conductor whenever magnetic field around a conductor changes. Then the electrical generators are based on this principle and they generate the electrical power. Then thermal energy is used to generate electrical energy. Such power plants are called as thermal power plants. Then in thermal power plants, the chemical energy in the coal is converted into electrical energy, and thermal power generation is a major way of electricity generation today. Students, now let's understand about the power plant based on nuclear energy. That means about the nuclear power plant. Now the energy released by fission of nuclei of uranium or plutonium atoms is used to generate the steam of high temperature and high pressure. Steam turbine is used to rotate the generator in the power plant based on nuclear energy, and the turbine is rotated due to the energy in the steam, and this further drives the generator to produce electricity. Students, now let's understand about the energy transformation in nuclear power plant. Now in a nuclear power plant, uranium or plutonium are used as fuel. Then during the fission of nuclei of atoms like uranium or plutonium, the nuclear energy is converted to thermal energy. Then this thermal energy is used to heat the water present in a boiler. Steam of very high temperature and pressure is generated and directed on the blades of the turbine. Then the kinetic energy produced in the steam is then used to drive the turbine. Then the turbine rotates the generator connected to it, which in turn produces electrical energy. So students, you can show the transformation of energy from nuclear energy into electrical energy by the given flow chart. Now students, can you recall how does nuclear fission take place? Yes, in nuclear fission, the atom of a heavy element is bombarded by a neutron to form an unstable isotope. The unstable isotope further splits into two or more smaller nuclei, releasing extra neutrons and energy. And in nuclear fission, huge amount of energy and heat is released. Now student, what are isotopes? Yes, isotopes can be defined as the variants of chemical elements that possess the same number of protons and electrons but a different number of neutrons. So in other words, we can say that isotopes are variants of elements that differ in their nucleon numbers due to a difference in the total number of neutrons in their respective nuclei. Students, now let's understand about the formation of nuclear energy. Upon bombardment by neutrons on atom of uranium-235, absorption of neutron takes place and it converts uranium-235 into its isotope uranium-236. And being extremely unstable, uranium-236 transforms into barium and krypton atoms through a process of fission. And this releases 3 neutrons and 200 mega electron volt energy. Now this mega electron volt energy is million times more than electron volt. And 1 electron volt is defined as the energy that an electron gains when it undergoes a potential difference of 1 volt. And in the SI unit, 1 electron volt corresponds to 1.6 multiplied by 10 raised to minus 19 joules. And students, this 3 more uranium-235 atoms undergo fission due to 3 neutrons generated in this process. Thus, more fission releases more energy. And the process of fission of uranium-235 atoms continues and is called the chain reaction. And in this way, a controlled chain reaction is carried out to release thermal energy, which in turn is used for generating electric energy. Students, now let's do one activity. In this activity, you have to complete the following table for some important nuclear power plants in India. Now here the place where the nuclear power plants in India is being given. You are supposed to complete the table by telling the state and the capacity in megawatts. So the first one is Kudankulam. Kudankulam is in the state of Tamil Nadu and the capacity is 2000 megawatts. Then the second nuclear power plant is Tarapur. Tarapur nuclear power plant is in Maharashtra with the capacity of 1400 megawatt. Then the third nuclear power plant is Rawatbhatta. Rawatbhatta is in Rajasthan and the capacity is 1180 megawatt. Then the fourth nuclear power plant is Kaiga. Kaiga is in the state of Karnataka and the capacity is 880 megawatt. Students, now let us understand the schematics of nuclear power plant. Now in a nuclear power plant, nuclear energy in the nuclei of atoms like uranium or plutonium is converted to electrical energy. A nuclear power plant consists of a nuclear reactor, a boiler, condenser, turbine, a generator, that is electric generator, and a cooling tower. Now in the nuclear reactor, nuclear fission of nuclei to atoms like uranium or plutonium occurs. Control rods are used to speed up or slow down the chain reaction. Then using the thermal energy released due to the controlled chain reaction, steam of very high temperature and pressure is generated in the boiler. Then the steam is used to drive the turbine, which in turn rotates the generator and the electrical energy is produced. The steam is converted back to water with the help of the condenser and the cooling tower. Once the steam is condensed back to water, it is recirculated to the boiler. Now, what are the advantages of nuclear energy? Yes, fossil fuel like coal is not used in a nuclear power plant. Hence, air pollution does not occur. And if sufficient nuclear fuel is available, it becomes a good source of electrical energy. Now, students, along with the advantages of nuclear energy, there are some problems of nuclear energy. Now, let us see what are the problems of nuclear energy. Radioactive and harmful radiations are emitted after fission of nuclei occurs. Then the nuclear waste requires very safe disposal, and very fatal accidents can happen in power plant which emits very harmful radiations. Now students, let's understand the power generation plant based on energy of natural gas. So in a power plant based on energy of natural gas, chemical energy in natural gas is converted to electrical energy. It consists of a compressor, combustion chamber, gas turbine, and a generator. Now, pressurized air is introduced in the combustion chamber using a compressor, and in the combustion chamber, combustion of natural gas takes place in the presence of air. And a gas at very high temperature and pressure is generated in the chamber, and this gas is used to run the turbine, which in turn rotates the generator to produce electrical energy. Students, now let's understand how the energy is being transformed in the power plant using energy of natural gas. Now, the chemical energy in natural gas is converted into kinetic energy, which is generated due to the combustion of natural gas. Then this kinetic energy is converted into the kinetic energy in the turbine, and further the kinetic energy in the turbine is being converted into the electrical energy. So we can say that the chemical energy in the natural gas is being converted into the electrical energy in the power plant using energy of natural gas. Students, now what are the advantages of power generation plant using natural gas? The efficiency is more. That means the efficiency of this type of power generation plant is higher than that of power generation plant based on coal. And moreover, since the natural gas does not contain sulfur, burning of natural gas results in less pollution. And students, you have to always remember that use of energy is unavoidable in our daily life, but controlled and careful use is very essential. Now students, let's think that which electricity generation process is eco-friendly and which not. Yes, electricity generation process using fossil fuels such as coal, natural gas, and nuclear fuels like uranium and plutonium are not eco-friendly. So which are the eco-friendly process? So the electricity generation from green energy sources like water reservoirs, wind, sunlight, biofuels, etc. are eco-friendly. So students, this was the end of module 2. Now let us summarize what we have learned. So we learned that the energy released by fission of nuclei of uranium or plutonium atoms is used to generate the steam of high temperature and high pressure. The nuclear energy is converted into thermal energy. Thermal energy is converted into kinetic energy of steam. Then kinetic energy of steam is converted into kinetic energy of turbine. And finally, kinetic energy of turbine is converted into electrical energy. Then atom of uranium-235 is bombarded with a neutron. The neutrons release more energy through fission of more uranium nuclei. And this process of fission of uranium-235 atoms continues and is called the chain reaction. A control chain reaction results in release of thermal energy, which is used for electric energy generation. Very high temperature and pressure generated by combustion of natural gas, and this gas is used to run the turbine. And in power generation plant based on energy of natural gas, three main sections are present, that is compressor, combustion chamber and turbine. And the efficiency of power generation plant using energy of natural gas is higher than that of power generation plant based on coal. And the natural gas does not contain sulfur. Burning of natural gas results in less pollution. Now students, this is an assignment for you all. So it's right or wrong. If the statement is wrong, you have to write the correct sentence. So the first sentence is, to drive the turbine we need a generator. So is it right or wrong? Yes, it's wrong. So the correct sentence is, to drive the turbine we need an energy source. Then the second sentence is, in a power plant based on natural gas, pressurized air is introduced into the combustion chamber using a generator. Yes, this sentence is also wrong. So the correct sentence is, in a power plant based on natural gas, pressurized air is introduced into the combustion chamber using a compressor. Now the third sentence, in the process of fission, uranium-236 converts into atoms of barium and krypton, releasing 2 neutrons and 200 mega electron volt energy. Yes, correct. This statement is also wrong. So the correct sentence is, in the process of fission, uranium-236 converts into atoms of barium and krypton, releasing 3 neutrons and 200 mega electron volt energy. Now students, the second assignment is, observe the following diagram and answer the questions. So the first question is, atom of which element is bombarded with a neutron? Yes, atom of uranium-235 is bombarded with a neutron. Now the second question, into atoms of which elements does the unstable isotope convert? Yes, the unstable isotope converts into atoms of barium and krypton. The third question, what is the given reaction known as, and which power plant makes use of this reaction? Yes, the given reaction is known as nuclear fission, and nuclear power plant makes use of this reaction. Thank you, dear students. I will be back with Module 3. Till then, goodbye and have a nice day.